Hello, everyone. Welcome to Theo-MathProblemSolver. In this particular episode, we are going to continue on the homogeneous linear differential equations. In our previous episode, we look at the various ways by which we can use that method to solve some ODEs. But in this particular example, we want to look at it from a different angle. Even though we are still using we are still deploying the same technique. But what if this question is kind of being restrained, being kind of put in a way that the solution must exist within a certain domain or within a certain region, and that's what this problem is about. This problem, we are going to ensure that the solution exists, or we are going to have a particular solution, not just a general solution. And as I mentioned in our previous episode, we kind of look at a situation where the solution may not be placed under a strict condition. But in this particular one, you are saying that, look, the solution must exist or must be subjected under a particular condition. That's what this problem is about. So stay with me even as we do. And at this point, if you have not subscribed to our channel, please do so. Subscribe, like, comment, and then share this content with your colleagues, your loved ones. Let's help demystify the myth around mathematics. Let's get going. Bye-bye. Let's get going. Let's get going. So we are given this problem. It says that we want to solve the initial value problem. Okay, so this is our initial value problems. We have t multiplying the first derivative plus 3y equal to 0, and it is subjected to y of 1 equal to t. Okay, but how do we solve this? Since this problem, remember, we said that this is separable. Okay, so separable means that we can kind of group the y's on one side, right? Okay, so in other words, the dependent variables on one side, we have to, then we kind of find a way to do some separation here. But how do we do that? How do we do that? And that is what we are kind of looking into. And we said that this can be written as, if you recall what we did earlier on, we claimed that this can be written as this, right? And then when we further do massage it a bit, we can write it this way, right? Does that make sense? Another easier way you may probably want to employ. So as far as understanding is concerned, I want to write it in a different way so that someone doesn't get confused here. Let me get rid of it. So we said that this can also be, if you don't want to get confused, you may want to write it this way. Okay. Then with this one, it means that my dy on y equal to minus 3 on what? Minus 3 on t dt. Okay. Now I can just take the differential on both sides. Okay. And by doing so over here, I'm going to have the natural log of y. You can, and then we said that this can give us what? 3 natural log of what? Of t, then plus some constant. Okay. And then over here, we said that we just have to exponentiate both sides. Okay. And by exponentiating both sides, you're going to have okay. And then by doing that, we said that the natural log and then the exponential function is they are inverse of each other, right? So in that case, you're going to have y of t equal to some constant, because we said that this can also be written as what? And e to the power c is such an arbitrary constant, right? So we can have, let's say, maybe a, okay, e to the power. Okay. Now, this is what we call this solution is what we call the general, okay? This is what we call the general solution. Now, since our problem was subjected to a particular initial condition, we may have to, make use of that. Okay. Now, our initial condition was, the initial condition is y of 1 equal to 2. But how do we use this? Okay, it just, so from here, it just means that wherever I see over here, I just means that wherever I see t, I should replace it by 1. Okay, then I equate the result to 2. Okay, very good. So let's take note of that. Now, what it means is that my y of 1 is equal to a multiplying e to the power 3 natural log of t. But then what is t? Remember, our t is what? From the problem, our t is 1, right? Which is equal to what? Which is equal to 2. But what is e to the power minus 3? What is e to the power? What is e to the power um e to the power minus 3 natural log of 1? Remember that we said that I think I mean, before we do that, we want to further simplify it here, just because we said that the natural log of the exponential and the natural log are inverse of each other, right? So we may want to do that. Is that okay? But this can we can further write this. We can further rewrite this as what, the natural log of t to the power hot minus 3. Is that okay? Does that make sense? And since they're inverse of each other, it means that my a will have something like this. Is that okay? So instead of this, it means that this one, I mean, just to make things a bit simpler, we may want to rather make it simplify it a bit, right? So it means over here, we're going to have 1 to the power minus 3. Does that make sense? Good. So on that note, we're going to have a equal to what? A equal to what? A equal to what? 2, right? So you're going to have that. Is that okay? Does that make sense? It means our a will be 2. So so this implies that my y of t should be equal to, it means that over here, wherever I see a, I should just replace it by 2, right? So in that note, we're going to have 2 t to the power minus 3, okay? Which can also be written as what? 2. Does that make sense? Yeah. So that's a solution to the problem that we just saw. I hope we are okay on this problem. And at this point, if you have not subscribed, please do so. Like, comment, and share this content with your colleagues, with your loved ones. Let's help demystify the myth around mathematics. So let's get going.